Hi guys, let's talk a little bit about friction. Okay, you probably learned back in elementary school that friction is like, the maybe a force that opposes motion or something that is between two surfaces that can create heat if you're rubbing them together. We're going to get a little deeper into what friction actually is, and on a microscopic level, friction. If you look at surface number one, okay, here's an artist rendition of surface number one, all blown up. Okay, so you have this is, let's say, is a surface of a hand. Okay, all blown up, and you've got the peaks and valleys. And let's say you've got another hand here. Okay, that you have that you've blown it up as well. Okay, magnified it quite a bit. There's peaks and valleys in both hands. Okay, so microscopically, okay, if I look at this area between, you notice that there are peaks and valleys that will eventually crash into each other. And this is what we call friction. Now, friction exists, with two surfaces in two different ways. There's something called static friction, and there's also something called kinetic friction. Statics is the study of objects that are still, and kinetics is the study of the objects that are moving. Now, static friction, now these little peaks and valleys, they rest quite nicely in here. They're stuck. Think of static as stuck. Okay, and then you can see the word, or the origin of the word looks similar to each other. Okay, so the static, stuck. So static friction is, a situation with static friction is if you're like pushing on a box like this, okay, and you've got a force on it, and the box does not move. Okay, you put a force on it, frictional force is equivalent. So in static friction, force of friction is equivalent to the force applied. So force of friction is equivalent to the force applied. So you're not getting any acceleration. Now, kinetic friction is moving. So let's say you get a situation here where you've got the block on the surface, you move it, friction's pushing you back. Okay, the force of friction is less than the force applied. So if you add these two up, applied and then also friction, then your net force does not equal zero. So in kinetic friction, the net force does not equal zero. Now in physics, we can make sense of this because it takes a little bit more to get something moving than to keep it moving. So if I'm going to move a refrigerator across a floor, it's hard to get it moving. But once it's moving, then you get a friction that's a little less. So we say that the static friction, okay, we'll call this F sub S, is always greater than the kinetic friction. Okay, and there are values that we can apply to the friction between surfaces. In any textbook or a chart that I'll probably give you, we can get the values of these frictional values between two different surfaces. So when we look at static friction, okay, we have something called the coefficient of static friction. This is pronounced mu. Okay, it's not a u, it's a mu. So this is a coefficient of static friction. And then we also have something called the coefficient of kinetic friction. Okay, and then we know that the mu values, static, is going to be greater than kinetic, okay, because it takes more force to get something to move. All right, so I've given you some information about friction, and now let's look at an example. Okay, we'll do that in the next video.